now that we know Kirchoff's rules, we can figure out stuff about more complex circuits. So in this case, we've got two batteries going on. We've got a bunch of resistors, and I want to find the currents going through each of the resistors. All right, and now that we know our Kirchoff's rules, we can figure that out. By using our junction rule, we can immediately get one relationship between I1, I2, and I3. If we look at this junction, we can see that current I2 is flowing into it, I1 and I2 are flowing into it, and I3 is flowing out of it. So we can say I1 plus I2 equals I3. All right, and then we can start writing our loop rules. We look at this loop, then we've got an increase of our E1, then we've got a voltage drop of our I1, R1, we've got another voltage drop of our I3, R3. Okay, we have three unknowns, so we're going to need three equations. If we draw this loop, this is going backwards through the battery. So that means, well, actually, yeah, first it's going backwards through this resistor, so that's a voltage increase of I1, R1. Then it's going backwards through the battery, so that's a decrease of E2. And then it's going through this, so that's a decrease of I2, R2. And then we're back to the same point. So, and around these loops, the voltage, the potential difference must be 0. And now we have three equations, three unknowns. If you arrange it into the form of a square matrix, you can use your calculator to solve, or you can, start substituting away. I've got I1 plus I2 equals I3, so we can substitute into that first equation. Like so. And then you can use our second equation to solve for, let's say, I2, because that'll be most convenient. I2 here would be, if we add this over, divide by R2, it's just I1, R1 minus E2 over R2. So then combining them, we get E1 minus I1, R1 minus I1 plus I1, R1 minus E2 over R2 times R3. Woo! Equals 0. All right. So, things can get kind of hairy with the algebra, but ultimately, we only have one unknown in here, the I1. Everything else we know. So we can do some distribution and move some stuff around. We've got E1 minus I1, R1 minus I1, R3 minus I1, R1, R3 over R2, distributing the negative, plus E2, R3 over R2 equals 0. And if we look, everything has units of voltage, E, IR, and E. All right, then we collect all of our terms, and we've got I1 times R1 plus R3 plus R1, R3 over R2, and that's equal to E1 plus E2, R3 over R2. So our current through the first resistor is E1 plus E2, R3 over R2 over R1 plus R3 plus R1, R3 over R2. All right, hairy algebra. E1 is 12 plus E2, 15, R3, 14 over R2, 20, all over R1, 16 plus R3, 14 plus R1, R3 over R2. Woo! And we punch that all into our calculator, and we get that I1 equals 0.546, etc., which I will store for later usage. And then I2, following that, I2 is equal to I1 0.546. Oh, I've gone off your screen. My bad. So this is what was going on here. This is just doing some algebra, plugging in the numbers. We get 0.546. Then I2, going back up to this equation, is 0.546, etc., times R1, which is 16, minus E2, 15, over, where'd it go? R2, which is 20. So we've got that times 16 minus 15 over 20. And that comes out to minus 0.313. So that means I2, I assumed, if we look back at our diagram, I assumed our current was going this direction through the resistor. So because it's negative, it is in fact going this way, which kind of makes sense. You got a battery here, which is going to push current that way. All right. And then I3, according to the junction rule that we wrote, is just I1 plus I2. Which is 0.233, etc. And these are all units of amps. So, again, like I said, algebra, not so pretty, but you can chug through it and get your answer. Alright, I'm going to do one more example here, and on the way, I'm going to remind you of how you can solve systems using your calculator, using matrices in your calculator. Alright, so we have a circuit going on here. We've got two batteries again. We've got 4 resistors this time, and a solving 3 equations for 3 unknowns is already getting a little annoying. Solving 4 by 4, that's just a pain. So we're going to solve this one in the calculator rather than doing it out on paper. First off, though, let's start punching in some stuff. If we make, we can first start by writing out a junction rule. We can write a couple things. First off, these 2 resistors right here are in series. They just you flow straight through each other. So we can right away say that the current flowing through those 2 is the same. I2 equals I3. All right. And we can also say that I1 equals I4 because the current that flows through R1 splits off here, but then it'll come back together and go through the R4. So these pairs are each equal to each other, which maybe actually might make this one easier to solve just by hand than whatever. So then we can start writing loop rules. Let's say we go around the loop to here. We've got a voltage increase of E1. Then we've got a voltage drop across this resistor, I1, R1. We've got a voltage drop across the battery, is the way it's situated, and a voltage drop across that second resistor. And of course, all that adds up to 0. Oh, this is going to be easy. Again, we've got a loop right here. So we've got another loop. We've got our voltage increase of E2. We've got a voltage drop, I2, R2, and another voltage drop, I3, R3. Okay, I'm going to have to get a different circuit. But this is just another example of how you can write these loop rules. And then I1 equals I4. So, you can just substitute in, and we've essentially got the answers to all of those currents.